Hey, good day. Welcome to JCSF online tutorial class, online physics tutorial class. My name is Mr. Humphrey JS, so your physics tutorial teacher. Today we have to continue with our topic that is at hand. We want to conclude it today, which is rectilinear acceleration. In our previous class, so we were dealing with rectilinear acceleration. So, and we stopped at the velocity time graph. So we stopped at the velocity time graph, and today we want to continue from where we stopped. Then here we'll be looking now we'll be looking into analysis of rectilinear motion. So under this, we are going to look into equation of motion. So we want to look into equation of motion. So for those of you who missed our class, so you can subscribe to JCSF YouTube channel. So for you to have access to our previous classes. So with that, it will be easy for you to meet up with everything that we have did. So without wasting much of our time, we want to start with analysis of rectilinear motion. And we want to look into equation of motion. Let us consider a body. So, considering a body, so with an initial velocity, a body with an initial velocity u, with an initial velocity u, moving in time t. So let the final velocity be v, and its acceleration be a. Now, in deriving the equation of motion now that I want to look into, we have to consider a body with an initial velocity u, moving in time t. Then we now take the final velocity v as acceleration to be what? To be a. The parameter we have here now are the initial velocity, the time, the final velocity, and the acceleration. So initial velocity is equal to u. Now, final velocity is equal to v. So the time taken is equal to t. So initial velocity is equal to the u, final velocity is represented by v, the time taken is represented by t. Now, let us start. Acceleration, which is a, is equal to, remember, when we're dealing with a fundamental and derived quantity and units. So we talk about acceleration is equal to change of velocity all over time taken. Acceleration is equal to change of velocity, so all over time taken. And when we talk about change of velocity means the initial velocity and the final velocity. And to get this, we can just say that the final velocity v minus the initial velocity u all over time taken t. So all over t. Then we can now do cross multiplication. When we do cross multiplication, a will multiply t. So this will be equal to at is equal to V minus U. So H is equal to V minus U. With that, oh, it's like the board is not showing. Let me continue at the top. Now, so H is equal to V minus U. So therefore, V will be equal to U plus 80. V will be equal to, if U plus, so it will become positive, then U plus 80. V will be equal to U plus 80. Now, we can take this as equation 1. Here now, that is acceleration. So equation 1. Now, let's now talk about the distance. The distance traveled. The distance traveled by the body. The distance traveled by the body in time, which is seconds. So the distance traveled by the body. Distance is represented by S. Remember, our distance is represented by S, which is equal to average velocity. Our distance is equal to average velocity times time. Average velocity times time. That is the distance. Now, when we want to talk about average velocity now, remember that change of velocity is equal to U, V minus U. But again, now we're talking about average velocity, distance, and distance is average velocity times time. Now, the average velocity now, S is equal to U plus V all over 2. This thing I put here now is average velocity. To find the average velocity of the that would be this would be equal to U plus V to all over 2. That's average velocity. So, but we said average velocity times time. This times T. You understand? So we can take this as equation 2. So, hope you following me. So we start with acceleration. Acceleration is equal to change of velocity all over time taken. We're trying to prove the equation of motion. Acceleration is equal to change of velocity all over time taken. And the change of velocity is equal to V minus U all over the T. So 80 is equal to V minus U. Now 80 is equal to V minus U. So V will be equal to U plus 80. So V is equal to U plus 80. When the U cross, it becomes positive, plus 80. Now, the distance travel by the body in seconds now. The distance travel by the body in seconds. So we've talked about acceleration now, and we have had V is equal to U plus 80 as our equation 1. So that's about distance. Distance traveled by the body in seconds. So S is equal to average velocity times time. So distance is represented by S, which is equal to average velocity times time. So our distance, if we go, average velocity is equal to U plus V all over 2. Average velocity is U plus V all over 2 times T. So we take this as our equation 2. So you have to take note. Now, our equation 1 is V is equal to U plus AT. Our equation 2 is S is equal to U plus V all over 2 times T. Now, but since V is equal to U plus AT, which is from equation 1. Then S, which is distance, remember this is distance, will be equal to U, this U, plus this U plus AT. U plus AT times T all over 2. We are not rushing. We're trying to put it in the simplest one so you can understand. Since our V is equal to U plus AT from equation 1, distance S, speed S, which is equal to S into bracket U plus V times T all over 2. S is equal to U plus V, velocity. So our velocity now is U plus AT all over 2. So that was the reason why we put this U plus AT here. So our velocity is equal to U plus AT, which is U plus AT all over 2T. No rush. You need to understand the concept. Since V, velocity is equal to U plus AT, but our distance is equal to U plus V all over 2 times T. So U plus V all over 2 times T. Speed will now be equal to the U plus V. This velocity now is U plus AT. Remember that velocity is U plus AT all over 2 times this T. Straightforward. So from there, we can now say this will be equal to U plus AT, U plus AT, T all over 2. U plus AT times T all over 2. Now, this will now be equal to S will now be equal to U plus U will give us 2U plus AT, 2U plus AT, T all over 2. All over 2. Now, this will be equal to 2 UT plus AT squared all over 2. Nothing complicated. So we know how we have at U plus AT, so over 2 times T. Then our speed will be equal to U plus U, 2U plus AT. t all over 2. Now, which should be equal to 2ut. We multiply this t by what's in the bracket. 2u times t, 2ut plus 80 times t, 80 squared, all over 2. That's as simple as that. So 2ut, this 2u here, when you multiply 2u by t, you get 2ut. Plus, when you multiply 80 by t, you get 80 squared, all over 2. So, keep on following. So, plus 80 squared, 2u plus 80 squared. So, our s is now equal to 2ut plus 80 squared. Let me put it out here. Our speed is equal to 2ut plus 80 squared all over 2. Now we can now do cross multiplication. And we do cross multiplication here. So this will be equal to 2 times s is equal to 2ut times 80 squared. You just have to get it straight. S is equal to 2ut, speed is equal to 2ut times 80 squared, all over 2. We cross multiply. This will be 2 times s, which is equal to 2ut times 80 squared. Therefore, this will give us 2 times s will give us 2s, which is equal to 2ut times 80 squared. Sorry, plus 80 squared. Now, we can now divide by 2. We now divide both sides by 2. 2 is equal to 2ut plus 80 squared. Now this will become 2s all over 2 is equal to 2ut all over 2 plus 80 squared all over 2. These two, we cancel this. I hope you follow it. So divide both sides by 2. So 2s all over 2, 2ut all over 2, plus 80 squared all over 2. 2 we cancel 2. This will be equal to s is equal to 2ut all over 2 plus 80 squared all over 2. Go for this is equal to s is equal to ut plus, if you want here, half at squared. So we take this as our equation 3. You just have to understand it straightforward. So s is equal to 2 all over 2ut plus 80 squared all over 2. 2 we cancel 2. This is equal to ut plus 80 squared all over 2, which is the same thing as half 80 squared. So that is our equation equation 3. Remember our equation 1, which is V is equal to U plus AT. Remember our equation 2, which is S is equal to U plus V all over 2 into bracket T. Now let us continue. From equation 1, I know our equation 1 is equal to V is equal to U plus 80. Our equation 1, V equal to U plus 80. Now, squaring both sides. Square both sides of the equation. Squaring both sides of the equation. Squaring both sides of the equation. And the equation is V is equal to U plus 80. Squaring both sides of the equation now will be equal to, this is equal to V square is equal to open bracket U plus 80 square. Now, with this now, this will be equal to, but it's not more visible. Okay, just keep on following. I have to clean the upper part of the board. Our equation 3 is S is equal to UT plus half AT squared. Plus half AT squared. Now, from equation 1, now it says V is equal to U plus 80. So by squaring both sides of the equation, V equal to U plus 80, this is equal to V squared is equal to U plus 80 squared. And this will give us V squared, which is equal to U squared plus 2UAT plus so U square 2UAT UAT square 2UAT plus 80 square. So squaring this side give you U square plus 2UAT plus 80 square. So now V square will now be V square minus U square will be equal to 2UAT plus A square T square. By calling the like term, V square minus U square is equal to 2UAT plus A square T square. A T square. Now, let us move on. Here now, we can now say B square minus U square is equal to this 2A into bracket UT plus half AT squared. I will explain. Half AT squared. Now, our V square minus U square is equal to 2UAT plus A square T squared. Now, V square U square will now be equal to 2 times A to the bracket UT, so plus half A T square, A square T square. So all over this, all over 2, that is half AT square. Two AUT plus half AT square. A square T square. Now, this one will give rise to our equation 4. What you need to know and understand is equation 3 was derived using equation 1. Equation 4 also was derived using equation 1 too. But equation 4 was derived using equation 1 by squaring the both sides of the equation 1. Why equation 3 was gotten by substituting equation 1 in equation. So our equation 4 is B squared minus U squared is equal to 2A into bracket UT plus half AT squared. This is equation 4. From equation 3. And what is our equation 3? Our equation 3 is equal to speed S is equal to UT plus half AT squared. So from equation 2 to equation 3, S is UT plus half AT squared. So this will be, which is what? Substituted into equation 4. Into equation 4. So thus we have B squared minus U squared is equal to 2AS. Let me put light on this. From equation 3, this is our equation 3. S is equal to UT plus half AT squared. Equation 3 is substituted into equation 4. Equation 3 is substituted into equation 4. This is our equation 4. V squared minus U squared is equal to 2A to bracket UT plus half AT squared. Our equation 4. Now, equation 3 is now substituted into equation 4. Equation 3 come up inside this bracket, UT plus half AT squared on inside the equation 4. UT plus half AT squared. This is equation 3 in equation 4. And we substitute this equation 3 just by S. So remember, equation 3 is speed. Speed is equal to UT plus half AT squared. Now, for writing this now, we just substitute equation 3 in equation 4 by saying B squared minus U squared is equal to 2AS. Therefore, we now say that b squared minus u squared is equal to 2as. Now this can now be equal to b. This can now be b squared is equal to, if this minus u squared cross, this is equal to u squared so plus 2as. We now take this as our equation 4. So our equation 4 will now be this. Remember, I say b squared minus u squared, you have 2 in the bracket, ut plus half 8 squared. This has been a long journey. So instead, we just substitute. So the equation 3, v squared minus u squared, and that's how we arrive at v squared, well, u squared plus 2as as our equation 4, which is just brief. So we also have an alternative method of getting the equation 4. The alternative method of getting the equation 4. So the alternative method of getting the equation, so equation 4. Now, from our equation 1, so our equation 1 is equal to b is equal to u plus 80. T can now be equal to v. If t cross, this is v minus u all over a. So t, that way, t will be equal to, when this one cross, v minus u all over a. But our speed will be equal to v plus u average speed all over 2. Remember average speed. So our average speed so is equal to v plus u times t, or average velocity, I mean. So all over 2. So with that now, our speed cannot be equal to v plus u all over 2. And b minus u all over a. Considering this, v minus all over a, so v minus u over 2t. So this is v plus u all over 2, v minus u all over a. V plus u all over 2, v minus u all over a. You know how we arrive at this? We know how we arrive at this too. So v plus u all over 2 and v minus u all over a. Therefore, our s will be equal to, if we multiply this by this, we get v squared plus, if we multiply this by this, we get u squared. If we multiply this by this, we get 2a. So from there, we can now say that when we do cross multiply here now, so we will now have, sorry, this is minus. If we do cross multiply, now we now have v squared minus u squared is equal to 2as. V squared minus u squared go to 2as. Therefore, our v squared will be equal to, if this one, if the minus u squared cause equal to equal sign, is equal to u squared plus 2as. So are the same equation 4. That is alternate method of the equation 4. So that is the equation of analysis of rectilinear motion. So that is the analysis of the rectilinear motion. So let's talk about the summary of equation of linear motion. Summary of equation of linear motion. 1, v is equal to u plus 80. 2, s, so remember s is equal to bracket v plus u all over 2t. 3 is equal to s, which is speed, is equal to ut plus half at squared. And the last one, because the v squared is equal to u squared plus 2as. So that is all you need to know about the analysis of the rectilinear motion and the equation of motion under the rectilinear acceleration. So with that, we have rounded up with the topic. Because of the time, so I will just throw it a question randomly. So I will treat 1 or 2 questions, then we move to another topic in our next class. So without wasting much of our time, because time is not by our side, our examination is almost here. So for reading our next class, we'll just briefly talk about solve 1 or 2 questions under the rectilinear motion. Then we move to another topic. So that is all about that. So once again, thanks for watching JCSF online online physics tutorial class. So I remain my humble self, JS. So till we meet next time, thank you and have a wonderful day ahead. Bye.